This chart shows how the Earth's temperature has changed over geologic time. The present time is shown on the far right edge of the chart. Way back in time, approximately 500 million years ago, is shown on the far left edge of this chart. I will point out that this chart was actually produced in 2015, approximately 8 years ago. Although the chart depicts temperature variation up to the present date in this case is actually 2015. The chart is made of 5 separate panels. The panels cover different periods of time. The first panel here covers the period from the present back 20,000 years. The next panel covers the period of time 20,000 years ago back to 1 million years ago. The third panel covers period of time from 1 million years ago back in time to 5.5 million years ago. The fourth panel covers a period of time from approximately 5.5 million years ago back in time to 66 million years ago. The fifth panel covers a period of time from 66 million years ago back in time to approximately 550 million years ago. Here we've zoomed into the first 2 panels from the right of the temperature chart. Again, this covers the first 20,000 years going back in time. This covers 20,000 to 1 million years back in time. This line here represents the average temperature of the Earth today, which was basically an average derived by taking a look at the Earth's temperature between 1960 and 1990 and averaging those values. That again is this horizontal black line. Note the chart going up and down here. These cycles are called Milankovic cycles. They represent the coming and going of glaciers in the northern hemisphere. The main cycles here occur about once every 100,000 years. I want to point out that during the preceding 4 interglacial periods, and we are currently in an interglacial period, which means that the glaciers have melted and retreated. The temperature of the Earth during the preceding 4 interglacial periods is substantially higher than it is today. The most recent one was approximately 5 degrees Fahrenheit warmer than it is today. The preceding interglacial period was approximately 125,000 years ago. After that, the Earth cooled and once again glaciers formed in the northern hemisphere and covered the United States, Canada, and Europe as well as other parts of the world. I will point out that when the period of glaciation was over and the Earth started to warm as depicted in this last panel here. Note that the temperatures slowly started to rise until approximately 13,500 years ago, when for some reason the Earth got cooler again and glaciers came back. But after about 1,500 years the temperature once again warmed up to near the present temperature, where we've experienced mostly level temperatures since. Here we've zoomed in and are showing the first 3 panels of the temperature chart. Note the period between 1 million and approximately 2.8 million years ago. These deviations you see in the temperature are also Milankovic cycles. However, over here they occurred approximately every 100,000 years in this range. But here they are occurring at approximately every 41,000 years. These Milankovic cycles between here and here are due to changes in the Earth's orbit, its tilt, and the precession of the axis of the Earth itself. I'll also point out that from about 3 million years back in time the average temperature of the Earth was much higher than it is today. I'll also point out that this period of Earth's history from here onward to the present occurs during a period of time when ice sheets are present over the northern hemisphere, particularly Greenland. The Earth is actually in an ice age right now. The Ice Age formally began back in time about 33 million years ago, when Antarctica first picked up its ice sheet. Anytime there is a permanent ice sheet on either the north-south or both poles, that period of time is referred to as an ice age. And we are in an ice age even though we have mild temperatures and even though there are no giant glaciers over North America, Europe, and Northern Asia. However, there is a permanent ice sheet over Greenland and Antarctica. Here we change the zoom value again on the chart and are displaying the first 4 panels. This green period again covers the period of time from about 5.5 million years ago to 66 million years ago. And by the way, it was about 66 million years ago when the asteroid hit the Earth and killed off all the dinosaurs. I'm going to point out that the average temperature of the Earth was substantially higher than it is today, approximately 25 degrees Fahrenheit higher back by around 52 million years ago. Finally, I've adjusted the zoom again on the chart showing all 5 panels. Once again, note the extreme difference in the temperature of the Earth from a high over 25 degrees from present back about 500 million years ago to an extreme low about 5 degrees below present about 300 million years ago. Although not displayed on this chart, there were several ice ages during these periods of time. There is an ice age approximately here and here, plus the ones that we have that started approximately 33 million years ago from here that we're still in. This is the current ice age geologically that the Earth is in, and during those ice ages we have periods where glaciers come and go and the temperature goes up and down in cycles. In this case from the period a million years ago to 20,000 years ago. These cycles are based on 100,000-year cycles and are due to the Earth's orbit around the Sun. I will also point out that many of the changes in the Earth's climate have been affected by the location of the continents on the Earth's surface. Continental drift has indicated that over geologic time the Earth's continents have moved all over the place. Approximately 3 million years ago the Isthmus of Panama was closed off, and that started the formation of an ice sheet over Greenland. Approximately 33 million years ago, right about here, the continent of Antarctica separated from South America and Australia, opening up what's called the Drake Passage and the Tasman Sea, which allowed water to flow around Antarctica uninterrupted. And that started the beginning of the current ice age at 30 million years ago. That's when Antarctica developed its ice sheet.